Good morning. My name is Megan Edwards of Focus Communications, and today we're bringing you another update from Eloro Resources, which trades on the TSX exchange under the symbol ELO. Joining me today is Dr. Bill Pearson, Executive VP of Exploration at Eloro Resources. Bill, thank you for your time this morning.
Oh, my pleasure.
So, Bill, for those who are new to the Eloro story, can you start by giving us an overview of the company and your Iska Iska project in Bolivia?
Sure, absolutely. Well, you can see this lovely picture here of this mountain. That's Iska Iska, a giant collapsed resurgent caldera that formed in the Miocene that, as I'll show you, has two potential world-class deposits, a tin deposit and a very large, extensive silver, zinc, lead, polymetallic epithermal deposit. Of course, usual caution on forward-looking statements. We have a huge resource set at Iska Iska, which we released in the fall of 2023. It's a huge deposit, over 560 million tons in the polymetallic and 110 million in tin. The criticism always was, well, it's low grade. But as I'll show you as we go through the results of our definition drill program, the reason it seems to be lower grade is just a function of drill hole spacing. And most of that resource is defined on very wide space drilling. And as we tighten it up, the grade goes up. And we've been focusing our recent work on this higher grade area near surface, this 132 million tons. And that's certainly firming up very, very nicely. So we're down here in the southern part of the famous Bolivian tin belt. This belt is quite enormous. It goes for about 1,000 kilometers from northern Argentina to southern Peru. San Rafael here up in the north end is one of the largest tin operations in the world. And we're down here in the south end, not far away from some very famous names like Cerro Rico de Potosí, Pan American San Vicente, Chirroque, which is a very large tin deposit operated by the Cooperativists, and San Cristobal, which is originally developed by Sumitomo, now operated by a private company, San Cristobal Mining. So we have a great address. And if we just look very quickly at the overall geology, you can see this black dash line here. That's our MRE pit. It's 1.4 kilometers in diameter. It gives you an idea of the scale. It goes down to about 750 meters below the Santa Barbara hill. And you can see also the wider dash line, which is the approximate limit of the caldera. So this was a huge volcanic edifice. The peak at Iska Iska, which is over here on the central breccia, is about 4,400 meters. The valley is at 3,300. So there's a kilometer of relief here. And it's just an absolutely remarkable volcanic complex. You can see the scale here. The magnetics tell you that the actual system is probably 5 by 3 kilometers. And where we've been focusing recently here is this red dashed area, which is the potential starter pit area in Santa Barbara. And you see this bluish unit here. This is an intrusion breccia, and I'll come back to that. That's an important new unit that we've recognized as far more extensive than we previously thought due to our additional drilling, and that's an important host of tin. And this just gives you an idea of our original resource picture here. And this red here is the starter pit area where we're concentrating our efforts in the definition drill program. And you can see the dimensions I mentioned, and plus stripping ratio is very, very attractive. So this is a huge deposit, even though we have 139 holes, almost 100,000 drilling. It's actually very sparsely drilled. Most of it's at 100-meter spacing, but we're changing that. We're doing more 50-meter in our definition drill program, and that's having a tremendous positive impact on the types of grade we're getting, simply because we're getting more representative sampling of the deposit.
I was going to say that last time we had you on, we discussed the high-grade tin discovery in hole DSP 72 that included 33 grading at 1.39% tin. And since then, the company has continued to report exceptional results in the infill drilling program. So starting with the February 20th release, can you walk us through the release where you announced an expansion of this major tin zone?
Yeah, absolutely. This was the initial release that Megan just mentioned. This is a tremendous tin hole. Certainly one of the best tin holes in the year for the last number of years. 33 meters, grading 1.39% tin within this larger zone, 87 meters, grading 0.74. And one of the key features of this zone is the cassiterite, which is a tin oxide mineral, which is the primary host of tin, is the very visible, coarse-grained, high-temperature cassiterite, which means that it's very likely amenable to very easy gravity separation. So in our next release here, we put out a second hole, 74, which is about 100 meters southeast of the discovery hole. And you see, again, we got almost 50 meters grading 0.55% tin within a large zone, 91.5 meters grading 0.34. And it also has a second lower intersection in this hole of 103.5 meters grading 0.3 tin, including 28 meters grading 0.44. So again, this hole really solidified the fact that we are into a very substantive tin zone. It's still very, very under-drilled, but the results to date are very promising. And it's in this breccia unit, which is very, very extensive, much more than past drilling indicated, because most of our past drilling was just relatively shallow and just caught the edge of this thing.
This week, the company announced further infill results from the Santa Barbara starter pit area, which included the highest grade silver intersection obtained thus far at Iska Iska. Can you walk us through the release and touch on the company's success on tighter space infill drilling?
Absolutely. This was a very, very exciting hole. Hole 75 intersected 151 grams silver per ton over 135 meters within a huge interval, 309 meters. That's more than 3 football fields, grading 90, almost 91 meters. And within this high grade intersection, we had a spectacular almost 1,000 grams silver per ton over 9.75, including a wider zone of 30.4.5 grading 440. Extraordinarily high. And this sort of level of grade is what we saw in channel sampling in the Santa Barbara adit, for example. And one of our earlier holes had an intersection of some 5,000 grams. So what this is telling you is that there's some substantive high-grade silver areas in the system. And when you get closer space drilling, you get better sampling and your odds of hitting it are greater. And how our drill program, definition drill program, has been progressing is really shown very nicely in this drawing here. You can see that these are all the various silver intersections, and I've color coded them. So the red is 50 to 100, purple is greater than 100. And you can see there's just a huge cloud of high grade values in the Santa Barbara area. That arrow there is 700 meters long. And just to give an overall framework to this, I put in a picture here at 3,900 meter level of the geophysics, the chargeability. And remember, chargeability, what it tells you is the electrical signature of the rock. So if you have pyrite, galena, other sulfides that are chargeable, what happens when you shoot a current into the ground and you shoot it in for 2 seconds, then shut it off, and you look at the reaction. So what happens with these sulfides is they act like little batteries and they grab the current. And we're talking milliseconds here. If there was nothing there, you would get no response and chargeability would be essentially zero. But you can see here, we have this huge zone of high chargeability here. North is off to the left here, going down to the south, southeast. And that is reflecting our epithermal domain, which is our silver, zinc, and lead. When we go over on the other side in our tin domain, which is the intrusion breccia I talked about, you can see that there's a tremendous contrast in the chargeability signature. It's very low. Well, why is that? Well, the tin zone doesn't have much sulfide in it. Cassiterite is an oxide mineral, which is not chargeable. So you can see the contrast between the two zones and how enriched this whole area is around here. And it's certainly open in both directions. You can see we have some intersections out here, but a lot of that is just a function of this drilling is very wide space. So as we fill it in, I think we'll see this expand even more. So this is very, very exciting. And obviously results of this level will certainly have a positive impact on our future mineral resource update.
And with both high-grade silver and tin zones in close proximity, how do you see the relationship between these two mineralization systems?
Well, that's a very good question. Here's a section through it that I think shows you quite, clearly we have the two. The tin is the first stage of this immense system. So you can imagine you're in this volcanic environment in the Miocene 13, 14 million years ago. You're in the Bolivian tin belt. So you have these huge tin porphyries coming up. So this intrusion breccia is basically what we call an apophyse. In other words, at the top of this tin porphyry system. The epithermal mineralization is still part of that overall volcanic event, but it came in at a later stage and essentially abuts this intrusion breccia. The interesting thing, though, is that the first part of this epithermal zone had zinc, some lead, and some silver. But there's a later part of this epithermal system that is dominantly silver, and that actually overprints the whole thing. So there's actually about 3 phases here, but fundamentally, we're looking at an evolving volcanic hydrothermal epithermal system where we have a magmatic tin deposit, and then we have an epithermal polymetallic deposit. And remarkably, these two immense systems are in the same place, which is quite extraordinary. This polymetallic epithermal zone is very similar to San Cristobal, but at San Cristobal, they're west of the porphyry belt, so they don't have the deep porphyry here like we do. And that's one of the, I think, extraordinary, exciting features about Iska Iska, is we do have potential here for two world-class deposits in the same place, which is really quite extraordinary. And, you know, the market has certainly recognized that Iska Iska is one of the largest undeveloped silver deposits around. And as we tighten up our definition drilling, we outline more higher grade material. Obviously, this average grade is going to increase. And if you sit back and you look at the overall system, here's the similar section I sold previously. You can see the MRE pit. It's open. You can see how the chargeability continues through here. The green is silver, and you can see how the green is all across here. But the purple, which is tin, is concentrated here in the northwest. And the whole thing is open in all directions. And if you look at it in 3D, this is the inverse magnetic model here in brown down here. This is the tin porphyry in the root. That's the block model with our initial MRE. And you can see it even clearer on this next drawing here, because I've shown the intrusion breccia domain, which is basically the low chargeability, in red. Here's purple, which is the high chargeability domain, which is our epithermal. And here's our magnetic anomaly, which is the potential tin porphyry. So you can see in general, this all makes a lot of sense. But look at the scale of this. I mean, that's 4 by 3 kilometers, almost 2 kilometers deep. It's an absolutely remarkable, massive system. And, you know, one of the key things in any exploration program, if you want to find a large deposit, get into a big mineralizing system. And there's no question that Iska Iska is an extraordinary mineralized system.
Can you briefly talk on the growth potential at Iska Iska, as you've had tremendous success in delineating infill and new mineralization in the latest campaign?
Yeah, absolutely. I mean, we've got two potential world-class deposits in the same place, which is extraordinary. The definition drilling has clearly shown that we need more definition drilling and to fill out that high-grade starter pit area, which will form the basis for the PEA, which we've actually done a fair bit of work on. We're in a very good jurisdiction. We're very positive about Bolivia. If you look at the critical mineral lists, tin and silver is very high on them. And we have both in the same place. We have a good operating team down there. And this whole system still remains to be fully explored. We have not defined the edges of it in any way. So we're at a very, I think, exciting stage here. I've been talking for some time that we need fill-in drilling. We need to do it at least 50-meter spacings. The results really speak for themselves. And this is really very exciting. And it shows that Iska Iska is going to take its place eventually as one of the great discoveries in the world for both tin and silver.
Absolutely. Thank you so much, Bill, for your time, and we look forward to having you back again soon with more updates from Iska Iska.
Thanks so much. Always a pleasure.